We were working on something called OmniTRACS. It was to provide a satellite link that would be continent-wide for medium and long-haul trucks to be able to have a two-way communication link with their home office and position location. We could come up with a small antenna that you could put on a truck, no mechanical parts, that could transmit a hopped signal to the satellite. The satellite, which were existing satellites, didn't need any special change. You just went into the one that was used for TV receiving and so on. But with the frequency hopping, we wouldn't bother anybody else, and then receive it. JPL had a contract out to get a similar antenna for a similar use, actually, but they were shooting for about a $50,000 antenna, and we were shooting for a $50 antenna. I kind of compared it to a device on police cars that showed a rotating light beam. You need a fairly narrow slot that you could rotate around, but it was one that you could transmit vertically over a wide area. And as a result, you could stick up a single probe into a waveguide. The waveguide would rotate around, the mouth of it would be the antenna. The other problem was position location. And so one way to get position location was LORAN, which came out of World War II and had some restricted, didn't cover the entire continental US, but it covered a reasonable part of it. So we thought, okay, we'd go ahead with LORAN receivers, until we found out that when you drove a LORAN receiver near a fuel station, a gasoline station where you get the truck refueled, the fluorescent lights or the neon lights jammed it. So how do you do it? Well, we came up with our own GPS signal. The communication signal was 1 megahertz wide and frequency hopped every 5 milliseconds over the full band of the satellite, of that transponder. We were able to do that, and we thought, knowing our own VSATs, that we would not interfere with VSATs, nor with TV signals, which were the two users of these satellites. They were jammable. And so we had to come up with another approach. And actually, Klein Gilhausen came with the idea, well, if we mimic a TV signal, so we hop it the same way the TV signal would sweep across the bandwidth of the transponder back and forth, if we did that, we'd be okay. Since we had enough transistors, we built a dual frequency synthesizer with our OmniTRACS system to test that and demonstrated to the FCC that we weren't jamming anybody. We put it in a van and had it drive cross-country, and to provide reliable communications back to ourselves, they took along one of the analog cellular phones that were used at the time. Well, they drove all the way to Washington. I met them in Washington. Along the way, the cell phone had sporadic use. Our OmniTRACS never failed. They got to Washington, and it was interesting. They went to the Hilton Hotel, and there was a metal awning overhead. They drove under it, and there was a pause, and then they began to receive signal again. And they couldn't figure out what in the world is going on here. And looking up at the awning, there was a little bit of a slit in it, and a signal could come through that, hit the building, reflect off the building, and our antenna was looking at the building, picking up this reflected signal. So it was a pretty impressive demonstration. In any case, we got permission from the FCC to go ahead and offer a commercial system.